Our question, you are given a maximum average subarray, easy. You are given an integer array num consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has a maximum average value and return this value. Alright, so what this question means is you'll be given an array of certain length of elements, and also you'll be given another value called k, which is also an integer. We are supposed to create a contiguous subarrays from the main array of length k. After generating the contiguous subarray, we are supposed to find which what is the maximum average we could find from the individual subarrays. Yeah. So okay. So considering the first example, if you are to split this main array into subarrays of length k, then we are going to have the first one to be something like 1, 12, negative 5, negative 6, then negative 5, negative 6. Then the next contiguous subarray is going to be like the next subarray following that is going to start from 12, then negative 5, then negative 6, then 50 instead of negative. We have 50. Then the next subarray we will get following that is the third subarray, is going to start from negative 5, negative 6, 50. Then the last value in the main array, that's 3. Alright, so our job to solve this question is to find the average of this, find the average of this, find the average of this, and return the maximum of this maximum of the averages that you have. Alright, so looking at this problem that consists of contiguous subarray, using the sliding window technique will be of good help in computing the sums of the subarrays in a very efficient way. So to solve this problem, first of all, we will need to compute the sums. Then after computing the sum, then we'll just get the average from there, and average is simply the summation of the individual items in the array over the number of items in the array. Alright, so let's jump to the solution. So to solve this problem, first of all, we have to compute the sum of the first subarray. And in this case, I'm initializing the sum of the first subarray into window sum, which is like the sum of the subarray, and we have the maximum sum, which is like the maximum sum we find from the subsequent subarrays. So once we find a sum that is bigger than the maximum sum that we have, we just replace the maximum sum with the current sum we have. But first of all, we have to compute the sum of the first subarray, which in this case is going to be 1 plus 12 plus negative 5 plus negative 6. Then we have that sum. Then the next thing we are going to do is now to iterate through the rest of the items in the array. So when we take out the first subarray, the elements of the first subarray out of it, now we iterate through the rest of the items to find the subsequent sums of the subarrays. But when you look at the previous example I had, when we look at this this explanation here, we will see that if we complete the sum, we are going to have 51. Yeah, 51. No, we'll have like this 13 minus 11, that's 2. We'll have 2. Then for this one, we're going to have 12. This one will give us 6. Then this one will give us 1. Then this one will be 51. I guess. Yeah, 51. Then for this one, I'm going to have negative 11. Then negative 11, negative 8. Then we are going to have 42. Yeah, 42. So if you should analyze these values carefully, realize that when we take the first subarray and we find the sum of the second subarray, we don't have to compute the whole sum again. All that we have to do is to remove the first value from the first subarray, the first value of the first subarray, in this case, which is 1. We remove 1 from it, then it's going to be like 12, then followed by negative 5, then followed by negative 6. Then we can add the next value in the main array, in this case, which is 50. So if we should sum this, we'll have the sum of the second subarray. And for the third subarray, we'll just take the first value of the second subarray out and add the value following the last value of the current subarray we have in the main array. That will give us the value of that will give us the sum for the next subarray. So using this explanation, let's go back to the code. Come on. Oh, I think I lost that. So after we compute the sum of the first subarray, then now we iterate through the other values, or the other values in the main array. So here we create a for loop, then we go through the remaining items in the main array. And what we do is this. So we say the window sum, that's the sum of the first that's the sum of the current subarray we have. We are going to take the previous sum that we had from the previous computation, then we remove the first value, we'll subtract the first value of the previous summary from it, then we'll add the next value of the next value after the last value of the previous subarray to the sum. Then after we compute this, we are going to do a check to find to see which of these two values is higher. So once we'll check the value of the current the computed sum of the current subarray, then we'll check it with the previous maximum sum that we had. So if the value of the current sum window, the current subarray is bigger than the maximum sum we already had, then we replace. Then after doing this computation, we can return the maximum sum. So over here, the maximum sum is going to contain the maximum value from the individual subarrays. So when we take one subarray, when we take the value, the sum of the values in there, and we take the other subarray, we take the values in there, the sum of the values in there, the maximum of those. That's what this max sum will contain. But to find the average of the subarray, we just divide it by the length of the subarray, in this case, which is k, and this value, this should give us the maximum average for the subarrays that we have.